So here I have a state diagram for a thread. State means a present situation, the current situation of something. Like my state is standing state now. If I am sitting, I am in a sitting state. So for objects or things, we use state. Like a car is in a running state. Car is in a parking state. So similarly, there are different states of a thread. So let us see through a diagram. The first state is new state. When you create an object of a thread, it will be in new state. And once you create, if you want to run it, then you have to call start method. So when you call start method, it will enter into ready state, means it is ready to run. It is ready to run. And in the previous video, I have shown you that if you call start, in turn, it will call run method, the one which we have to override, right? The method in which we have to write down threads functionality. This method will be called. So once you call start, this will call run. So after calling start means it's ready to run, and this start will call run method and it will enter into running state. So thread is running. Now after running and completing its task, thread will enter into terminate state. By itself it will terminate, right? Once its work is over, it will enter into terminate state, means thread has finished. And one more thing I would like to add here, that if a thread has started and terminated, you cannot restart again. You need a new thread once again. So this thread is over. Thread object has finished. So if you want same functionality, start a new thread and again start it. So a thread which is terminated is just like a thread is killed, so you cannot start again. Then there are other states also. Let us see. While running, if a thread is running, then it may enter into wait state. Wait state means it's waiting for acquiring some resource, or it is made to wait by some other thread. So it is in a waiting state. Now let us look at other states. When a thread is running, it may enter into wait state. So a thread may be waiting for acquiring any shared resource or shared memory. So it goes into a waiting state. So if it is trying to acquire some resource, then it has to wait. Now let us look at other states. There are three more. Among this, I'll show you this one first. See, when the thread is running and you want that thread to delay for some time, for no reason, just you want it to work slowly, then you can make it delay by using sleep. You can make the thread sleep for few milliseconds and again it will start running. So if you feel that it is working, like suppose in animation, you want to move a car or a ball and you find that it is moving very fast, you can slow down its speed by putting sleep, right? In between, it will sleep and then move, sleep and then move. So the speed will be less. Or if there are multiple balls and you want them to move with different speeds, then you can have different amount of sleep for each ball. So that sleep will make it delay for some time. So you have to mention the time. So running state to timed wait state, or you can say it's a sleep state also. And once the sleep time expires, it will again start running. So you can make a thread sleep and continue running, sleep and continue running. In that way, you can make the thread works little slow. Then there is also one more method called wait, and you can make the thread wait by mentioning the time. So it is more like sleep only. Now, next two more states are there, wait state and block state. So for this, I have to give you a little bit background. For that, I will draw a diagram here. Here you can see there are two threads and they are accessing same resource, one resource. Let us say it is a file or it can be anything. As an example, I wrote it as a file. So there is one file and two threads want to read that file. So here I have a diagram to explain the concept of synchronization. We will learn about this in the coming topics in very much detail. Little bit idea I am giving you to complete this states. See, there are two threads and they want to access a resource, that is a file, for example, file. Both want to access the same resource. we should not allow both to access same resource. Like it is just like there is only one paper and two people want to write simultaneously on that. We cannot allow. Let one person finish, then the other person can continue writing on a single page or a single book. So a resource should be handled by one thread at a time. So for that, if this thread is accessing, then this thread should wait. And once this thread has finished, it should inform the other thread that I have finished using it. Please, you can continue your work. And if suppose meanwhile when this thread is accessing it and this thread wants that same file again, then in that time it should wait. And when this thread has finished, it should inform it that I have finished using, you can start using it. Like it happens at many places, right? In our daily life, we find that suppose in an office, there is only one printer, more than one employee is using same printer. So they will take their turn, like I am using it, you please wait for some time. Once I finish, I'll inform him, I have finished, you can start using it. So that's what the coordination is there between the employees for using a common resource. Now, same way for using a common file, threads should have some coordination. So one should wait and the other one should notify it. So for that, there are two more states. Waiting state, waiting state. So if a thread is waiting, it enters into waiting state, doing nothing, just waiting for its chance. And once it gets notified by other thread, it will start running again and using the resource. So this is notify method, wait and notify. Then if the thread is requesting for a resource, so usually when it doesn't want anybody to access, it will put a lock. That locking mechanism is called as monitor. Anyway, we will learn this in detail. Just to complete states, I am discussing this. So to acquire a lock or to enter into monitor, a thread may request for some accessing some IO, then we say it entered into block state. So block state is just like waiting state. Once it enters into block state, then next is it has to wait. So it is like this. It is waiting for the resource, and once it is notified, it will go into block state, acquire the resource, then again it will come back and continue using the resource. So it will enter into monitor. So this is the state diagram. So we have learned few new things here. So this was just the introduction. Some things we already know it. So we have learned these things new, right? So this is a bigger topic on this one. So this is a separate topic, that is synchronization in multi-threading. You will find a video on this one. So that's all about the states. Now next I will talk about priorities.